Welcome to our introduction to Time Division Multiplexing or TDM. In today's fast-paced digital world, efficient communication is key to connecting devices, people, and services. TDM is a technique that plays a vital role in achieving this efficiency. Time division multiplexing is a method of transmitting multiple signals over a single communication channel by dividing the time available and the channel into distinct time slots. Each signal is assigned a specific time slot during which it can transmit its data. This technique enables efficient use of the communication medium, allowing multiple data streams to share the same channel without interference. Synchronous time division multiplexing is a specific type of time division multiplexing where multiple signals share a single communication channel by assigning fixed time slots to each signal. Each signal occupies its time slot in a regular repeating sequence regardless of whether the signal has data to send during that time. This method is particularly useful in digital communication systems. Key characteristics of synchronous time division multiplexing are fixed time slots. Each signal is allocated a fixed time slot in a predetermined schedule. For instance, if there are four signals A, B, C, and D, and the time frame is 1 millisecond, each signal might receive a 250 microsecond time slot. Time slot 1 signal A, time slot 2 signal B, time slot 3 signal C, time slot 4 signal D. This sequence then repeats. Deterministic behavior. Because each signal has a predetermined time slot, the behavior of the system is predictable. The deterministic nature is beneficial for applications that require consistent performance such as voice communication. The fixed structure of a synchronous time division multiplexing makes it relatively easy to design and implement. The logic required for managing time slot is straightforward as each signal transmission timing is known in advance. And finally, synchronization. The transmitting and receiving devices must be synchronized to ensure that the correct signal is sent and received during its desired time slot. This requires a clock signal that maintains synchronization. Asynchronous time division multiplexing are also known as statistical time division multiplexing. It is a more dynamic and efficient form of time division multiplexing where time slots are allocated to signals only when they have the data to transmit. Unlike synchronous time division multiplexing, where time slots are fixed and assigned to each signal, regardless of where or not data is available. Asynchronous TDM optimizes the use of bandwidth by dynamically allocating time slots based on demand. Some of the key characteristics of asynchronous time division multiplexing are dynamic time slot allocation. Time slots are not fixed for each signal. They are given to a signal only when it has data to send. This makes the system more efficient since it does not waste time slots on signals that have nothing to send. For example, if signals A, B, and C are sending data but signal B has no data, then the signals A and C can use the time slots that would have gone to B. Signal multiplexing. The system assumes not everyone will need to send data at the same time. By using this assumption, the system can be flexible in assigning time slots. It allows more users to share the communication line without wasting bandwidth. No wasted time slots. In asynchronous TDM, if a signal does not have a data to send, the time slot can be given to another signal. This way, no time is wasted. It maximizes efficiency by making sure every time slot is used. Addressing and control. Each time slot includes information that identifies which signal or user the data belongs to. This helps the receiver know who the data is from. Multiple signals can share the same channel without confusion. The advantages of time division multiplexing are efficient bandwidth usage, maximizes the utilization of available bandwidth by allowing multiple signals to share the same channel. Reduced interference. Since each signal is transmitted in its time slot, there is minimal risk of interference, ensuring better quality transmission. Simplicity. TDM systems can be simpler to design and implement compared to other multiplexing techniques, particularly in digital communication. Deterministic behavior. In synchronous TDM, the predictable timing of slots makes it easier to design systems for specific applications. The disadvantages of TDM are inefficiency in synchronous TDM. Fixed time slots can lead to inefficiencies, especially if some users have no data to send during their allotted slots. Latency, the wait for a time slot can introduce delays in communication, which may be problematic for real-time applications. Complexity in asynchronous TDM. While more efficient asynchronous TDM requires more sophisticated control mechanism to manage dynamic slot allocation. The applications of TDM are telecommunications, used in digital telephony to combine multiple voice calls over a single line, such as in integrated service digital networks systems. Data networks employed in data transmission systems where multiple users share a communication channel, improving overall network efficiency. Broadcasting, utilized in broadcasting systems to transmit multiple television or radio channels over a single frequency band. Used in satellite communication system to manage multiple data streams from various sources. It is implemented in some wireless systems such as WiMAX to efficiently allocate time slots for different users. Thank you for watching.